Good morning, children. After finishing one easy part, that is 10.1 and 10.2, let us move further towards the last part, that is 10.3. Keep your textbooks along with you while watching the video. We have discussed about the faces, edges, and vertices. Here is a riddle for you. I have no vertices. I have no flat faces. Who am I? Yes, you have guessed it right. It is the sphere. We have already discussed in our Google Meet about the faces, that is the surfaces, then about where the surfaces meet, the line segment, are known as the edges, and where the edges meet, the points, they are known as the vertices. Now, such solids are known as polyhedrons. We have seen that polyhedrons have surfaces which are known as faces and they meet at edges. Now, they should not be open from any end. So, on this page, there are certain solids which are polyhedrons and the others which are not polyhedrons. Now, we'll see what are convex polyhedrons and what are regular polyhedrons. In convex polyhedrons, you will see, in polyhedrons, they should not be curved faces. Similarly, in convex polyhedron, the intersection of the diagonals will lie in the interior, similar as convex polygons. Then, the concept of regular polyhedrons, where the shapes which are making the polyhedron are made up of regular polygons, okay, which are equal in length. In regular polyhedrons, the number of faces meeting at the edges remains the same. Here you can see in the first figure, it is a regular polyhedron because on each vertices, 3 faces are meeting. Whereas in the second figure, somewhere 3 faces are meeting and somewhere 4 faces are meeting. Other than cube and cuboids, even the prisms and pyramids are called as polyhedrons. Now, in prisms, only the 2 faces are triangular and the remaining faces are parallelogram. And in pyramid, the base shape is different and the remaining is triangular in shape. So the pyramid is known by the shape of its base. Now let us move towards do this activity. Here you will have to count the number of faces, vertices and edges. Then you have to add the number of faces and vertices and you have to add 2 to the number of edges and fill the table. After filling this table, you'll be surprised to see that the addition of faces plus vertices, that column and the last column, will have the same numbers. So here we come to an inference on a relation between faces, vertices and edges. That is, if we subtract the number of edges from the sum of faces and vertices, we'll get a constant number, that is 2. This relation is known as Euler's formula and it is true for any polyhedron. Exercise 10.3 is based on Euler's formula. Now, the first question says, can a polyhedron have these faces? 3 triangles, okay? No, it's not possible to have 3 triangles as a faces of polyhedron. It should minimum have 4 faces. The second bit asks for 4 triangles. Yes, a triangular pyramid has 4 triangular faces. The third asks for a square and 4 triangles. Yes, it's possible. A square pyramid has a square base and 4 triangular faces. Okay, moving towards question number 2. Is it possible to have a polyhedron with any number of faces? It is possible that the number of faces should be 4 or greater than 4. Okay, minimum it should be 4. Now moving towards question number 3. Which are the prisms among the following? The first one, you see, it is a nail. It is having a curved surface. So it is not a polyhedron. Okay, and hence it is not a prism. The second is a pencil. Now if you see, it is an unsharpened pencil which is having faces. So it is a prism. Now third is a table weight. Yes, it is not a prism. As you can see, the vertex where the faces meet, it is not the same. Now the next one is a box, and yes, it is a prism. Question number 4. How are prisms and cylinders alike? Now if you look at a cylinder, it looks like a prism with a circular base. Okay, and question number 2 is, how are pyramids and cones alike? Now a cone can be a circular pyramid, means a pyramid with a circular base. We have seen the pyramid is known by its base. So this way it can be similar. Question number 5. Is a square prism same as a cube? Imagine a square prism and you will identify it as a cube only. Yes, a square prism can also be identified as a cube. A square prism has a square as its base. Okay, now the side of the square can be different, so we can also identify as it a cuboid. Okay, not necessarily only the cube, but it can also be a cuboid. Now question number 6. Verify Euler's formula for these solids. So the first one, as you can see, can you count the number of faces? 1, 2, 3, 4, 5, 6 and 7. Okay, one at the top, second at the below, and you can see it is a pentagon, so it will have 5 side faces. Now you'll have to count the number of edges, that comes to 15, and the number of vertices, which comes to 10. So if we find out the relationship, that is F plus V minus E is equal to what? So F is 7 plus V is 10, and 10 minus 15 comes to 2. Hence, the Euler's formula is verified. Now, in the second figure, can you count the number of faces? Yes. Above there are, for the first the lateral faces, which is looking like a cuboid, so it is 4, and the bottom one, that is 5, and above also there are 4 triangular faces, so the total comes up to 9. And the vertices comes up to 9. Okay, the number of edges are more here, So if we count, it comes to 16. And substituting in the Euler's formula, F plus V, that is 9 plus 9 is equal to 18, minus E, which is 16 edges. So 18 minus 16 is equal to 2, and hence again the Euler's formula is again verified in the sum number 2. This figure was little bit confusing, so I thought of giving you the solution to this exercise. Okay, children? Now let us move further towards our next question. Question number 7 says, using Euler's formula, find the unknown. Now here we have three quantities: faces, vertices and edges. Out of three, two will be given and one will need to find out, as we have a constant 2 along with us. Okay, so in the first sum, faces need to be found out, vertices and edges are given. So if we'll keep faces on right hand side, not right hand side, we'll keep faces on left hand side, and we'll take vertices and edges on right hand side. So it will become 2 minus V plus E. Okay, so 2 plus E is 2 plus 12, that is 14, and minus V, that is minus 6, and which comes to 8. So number of faces is 8. In the second sum, the number of faces is given, that is 5, and number of edges is given, that is 9, and we need to find the number of vertices. So we'll keep the number of vertices on left hand side, and we'll take minus 9 and plus 5 on right hand side, and hence we get the answer vertices is equal to 6. And in the third sum, we need to find the edges. Keep the edges on one side, and after calculation you'll get edges as 32 minus 2, that is 30. Now comes the last sum. Can a polyhedron have 10 faces, 20 edges and 15 vertices? Euler's formula is also used to verify that whether the given data is of a polyhedron or not. So we'll substitute the value in Euler's formula and find out whether LHS is equal to RHS. So do this. So we will add number of faces and number of vertices. So 10 plus 15 comes to 25, and we'll subtract the number of edges. 25 minus 20 is 5, which is not equal to right hand side. So this data does not satisfy the Euler's formula. Hence the given data is not of a polyhedron. Hence we complete exercise 10.3 and our syllabus for the government periodic exam. So children, write down what we have discussed and revise the syllabus of government periodic exam. Best of luck. You will have your exam on 30 and 31st of December. So prepare nicely, revise everything, and you have any doubt you can ask me. Today we will not have Google Meet because we have finished this chapter and have given you the solution as well. So we have nothing to discuss. But yes, early bird competition is on, and exactly at 12:30 I will post the name of early birds, those who are sending the exercise 10.3 on my mail. Yes, already I have got some advanced early birds name. Okay, children, enjoy learning. Bye. See you.
Thank you.